Okay, now we are going to start calculus. Basically everything up to this point is stuff you've seen. 1.3, the limit of a function. So the limit is really the heart of calculus, and that goes for Cal 1, Cal 2, Cal 3. Everything in calculus is based upon the concept of a limit. So this is important stuff. Alright, let's start off 1.31. Discuss the behavior of this function around the value x equals 2. So we're going to take a look at a function, and we're going to look at the x value of 2 and see what's going on. So let me just first get to the function. Here it is. And here's the x value of 2. And at 2, it looks like we have a value of the function around 8. And so what we want to do is not look at what's happening at 2, but what's happening around 2, like in this area. So what I'm going to do is I'm going to show a left side approach. So I'm going to approach the value of 2, that's an x value of 2, from the left side, and if you move this over, you can see that I have the corresponding y value, or value of the function, right here. So when you plug in 1, you get 3. As I get closer and closer to 2, it looks like the function's value is growing and growing and getting closer to 8. Now what I can do here is I can step back and forth here, closer, further away, and this is how much I'm stepping by. Right now as I step, I'm just going 1/10 each time. So if I click this 1/100th, now I'll step closer, see, closer to 2, but now I'm going by hundredths. So 1.92, 1.93, 1.94, 1.95, 1.96, and you can see the y value is getting closer and closer to 8. Now I'm going to go even, well, let me get real close, 1.99. So it's real close, 7.9598 is how close I am to 8. Now, even finer, I'm going to step by 1/1000. So as you can see, 1.995, I'm getting closer and closer to the value of 8. And of course at 2 it is 8, but that's not what the limit's about. The limit is about what's happening as you get close to 2. I'm close to 8. Now let me do the same thing, but do it from the right side. So I'm going to start out here, somewhere over here. I have a value of 5 for x. I'm going to start coming in here. Look at my value is 3.659 is my x value. My y value is 4.5 right now. Notice when I was over here, my y value is negative because I'm below the x-axis. And so now I'm getting closer. So what happens here? I'm getting closer to 2 from the right side. So I'm at 2.81. Look at my y value. It's up here at 9.28. So I've gone past 8, and then I'm coming back down. And again, I'm getting closer and closer and closer and closer. Let me do it by 1/10 here. So I'm getting real close to 8 now. I'm going to go, let's go ahead and go real fine with that and see what happens. I'm getting closer and closer to 2, and the y value is getting closer and closer to 8 again, as you can see right here. So we're coming into a value of 2 from the right, and the value of the function is coming closer to 8, but it's actually bigger than 8. Notice when we were doing it from the left, it was smaller. Now we're bigger. But we're still headed towards 8. Okay, now let's look at the next example. We have another function. This is the actual function. It's a piecewise function. So we have some sort of jump here now. So let's see what's happening at 2. At 2, looks like we have a hole here, but a solid dot here, which means the value of the function at 2 is 8. But coming in from the left, things are a little different. I'm coming in, I'm still approaching, my value of x is approaching 2 from the left, and my y value appears to be approaching 8, right? And let me get close right here. Let me go a little finer. Again, I'm approaching 8 with a y value. I can get even finer, and I'm approaching 8 from the right. From the left. However, if I come in from the right side instead, what will happen is I'm down here, I've got some negative values, I'm going to start coming up here, and now I go up, I go up to about 5 or so, come back down. Now look what's happening here. From the right side as I approach 2, you can't really see it there real well, but as I'm approaching 2 from the right, my y value, right, my y value is not approaching 8. It's approaching this down here. So let me go a little finer here. So you can see I'm starting to approach 4, it looks like. And as I go even finer, you can see here that my y value appears to be approaching 4. So from the left side, as we approach 2, from the left, our y value is approaching 8, but as we approach 2 from the right, our y value is approaching 4. So these are very different things that are happening here from the left and from the right. Let's look at the next example. Discuss the behavior around 2 again. So this is very similar. This is another piecewise function. What's happening though is at 2, my function, I have a hole here and a hole here, which means the value of the function at 2 is 6. As I approach from the left, I'll go a little quicker through this now. The value of the function appears to be approaching 8, right? And let's go pretty fine here. Start approaching, it looks like it's approaching 8. As I approach from the left, as I approach from the right, the value of the function appears to be approaching 4 again, right? So I can start moving closer and closer and closer and closer. So from the left I'm up at 8, getting close to 8. From the right I'm getting close to 4, but at 2, at exactly 2, it's not 8 or 4, it's 6. So this is different than the previous 2 examples completely, because what happens at 2 is completely different than what happens from the left and from the right. Alright, next one. Discuss this function's behavior around 2. So here's our x values. Can't really see it here. This is -2. That means this is +2. As I approach from the left side, first of all, I'm way out here, so I'm on the function, and I'm going to go whoa and start going up to infinity or something. Something crazy happens. But as I keep coming towards 2, the value of the function appears to be approaching, well, this is kind of hard to see. Let's see. It appears to be like -2.5. Let me see. I'm going to go even finer. Yeah, about -2.5 is what it looks like it wants to be. But what's happening, which is a little misleading, is at 2 exactly there's an open hole, which means our function's not defined there. That happens to be because when you try and plug 2 into this function, you get 0 on top and you get 0 on bottom. So at 2, you get basically your function's undefined, 0 over 0. But we can still approach 2 from the left, and it looks like as we approach 2 from the left that we do get closer to some value. It was like -2.5, I think is what we said. Let me try and get back in there. Here we go. Yeah, so as we got real close to 2 here, 1.99, our function's value appears to be -0.250063, so real close to -2.5. Now when I come in from the right, what happens is, it's going to start coming in here. There it is. So my y value here is -1.83. That's how far it is down. And as I start coming in closer and closer to 2 from the right, it also appears to be approaching, oh, I went too far. It appears to be approaching -2.5 again from the right. I'll go finer here. So I'm at -2.493. So go a little finer. That's as close as I can get without actually being there. -2.49938. So really close to -2.5 when I come in from the right. Really close to -2.5 when I come in from the left. But at 2, the function's undefined. So again, the idea of the limit is not what's happening at 2. It's what's happening as we get close to it. So that's what this is saying up here. All right, next one. let's discuss the value, the behavior of this function around 0. So I'm going to go to a different x value now. Okay, so for this function, sine of x over x, at 0, if you plug in 0, you get sine of 0, which is 0, divided by 0, that's undefined. So we have a hole here at 0. However, if you start plugging in values from the left, you can start to see, from the left and as we approach 0, you can see that our function is going somewhere. It's headed towards something. I'm going to go finer here. Looks like it's headed towards 1. Even finer. Let's see here. That's about as close as we'll want to get. It's rounding off there. It's saying it's 1, but really 0.999999. So when we're really close to 0 from the left side, it's headed towards 1. The function's value is headed towards 1. As we come in from the right side, same sort of thing happens. You can see it here. I'm growing. It's negative. It's 0.77. And as I get closer, oops, wrong one. As I get closer and closer, it's starting to go closer and closer to 1. I'm going to pull this other one out completely so you can see it. So getting closer and closer, and from the right side as I approach 1, it's getting 0.99 something, 0.999296, even closer. I'll go even finer, and you can really start to see that sucker's getting really close to 1 again. So again, from the left, this function is as we approach 0 from the left, the function is approaching 1. As we approach 0 from the right, it's approaching 1. But at 0, the function is undefined. Alright, how about this one at 0? Whoa, this is some crazy stuff happening here. So sine of 1 over x. Let's talk about what's happening at 0 first. At 0, the function is undefined because you have 1 divided by 0, which is undefined. So the whole function is undefined at 0. But as we get closer to 0, some craziness is happening. So I'm going to try an approach here. So here I come. Here I come. And now I'm going to go to a finer step. Let's see what happens. This thing goes up. Wonder why it's going up and down. Probably because it's sine, right? It's going up and down and up and down and up and down. Let me go even finer here. It's going up and down and up and down, back and forth, up and down and up and down and up and down. We know that at 0 we can't plug it in, but we can plug this in and get some value. So this function appears to be oscillating up and down as we approach 0 from the left. Same thing happens when we come in from the right. As we approach 0 from the right, we start out up here, it goes up and then down and up and down and up and down, and start oscillating again. Now I can zoom in. I'm going to zoom in real close so you can see it. Now you can really see the function jumping up and down. Now it looks all jaggedy here, and that's just because there's some limitations to the software. It's having trouble figuring out what's happening in here. But for us, what we need to keep in mind here is that our function's not approaching any value like it had been previously from the left to right. It just keeps on oscillating up and down. So that's what I say here. From the left, we're oscillating. From the right, we're oscillating. And at 0, the function is undefined. Okay, next one. What's happening around 0 here? So here's 1 over x. At 0, the function's undefined. You'll recognize this is one of the functions you're supposed to know. Well, let's approach 0 from the left. So here we come. What's going to happen to our y value? It's starting to take off. Starting to go negative values here. Negative 5 point some, negative 10, negative 11. It's taking off. It's taking off. It's taking off. Negative 25. Let me go even finer. We're at negative 100. We just keep going. I mean, that sucker's just headed off where? It's headed off to negative infinity. It's just going to keep going down forever. So as we approach 0 from the left, our function's value approaches negative infinity. If we try and approach the function from the right, something a little different happens. We start coming in from the right, our y values start to grow. They start to grow larger positive values. Here I'm at 10. If I go finer and start coming in, now I'm up there, at 20. There I'm at 100. If I go even finer, I'm starting again to get huge values, huge positive values for my y. And so that one's taking off to infinity, but this time it's taking off to positive infinity. So what we say is that as we approach from the left, the function appears to be going to a negative infinity, so we approach from the right, positive infinity. And of course at 0 again, we said it's undefined. Now, this one, 1 over x squared. Let's see if we can do this one. So we're going to approach 0. Of course at 0 it's undefined. As we come in from the left, the function's taking off to infinity. As we come in from the right, it's taking off to infinity also. So you can see this. I can just animate this a little bit. I won't go through it in detail again like I did the previous two. But from the left and from the right, our function's values are taking off to positive infinity. So from the left and the right, positive infinity on both. At 0, the function's undefined. So the general idea of the limit, basically when we find the limit of a function at a point x equals a, we are inspecting the behavior of the function near x equals a. We do not care about the actual value of the function at x equals a. When we inspect the behavior of the function, we can approach a from the left side or the right side. When we approach from one of the sides, one of the following can occur. So when we come in from the left or right, one of these things will happen. The function will approach some value, some number. We saw that back in some of these earlier problems. Let me see. Here, like from the left, we approach some value, right? We were approaching 8 here. We were approaching 4 here. So we can approach a single value, or it could oscillate. We saw the oscillation a little while ago. Or we could say that the function goes to positive or negative infinity. Excuse me there, my phone was ringing. Alright, so those are the three things that can happen. Remember, I can't stress this enough, we do not care what's happening at the value of the function itself. When we are talking about a limit, we do not care. And this is what makes this a calculus topic. You know, in college algebra, we could evaluate a function at a point and we just figure out whatever the value is. Here, limit, we don't care about that. I mean, we do, but it's not what we're focusing on. Okay, next note. Alright, the general idea of the left and right hand limits. As we discussed above, the limit involves inspection of the function as we approach some value of x. We can approach it from the left or the right. When we approach from the left, we call it the left-hand limit, or the left-handed limit, or the limit from the left. There's a couple of different ways you can say it, but I'm going to say the left-handed limit, or left-hand limit. When we approach the value of x equals a from the right and inspect it, we call it the right-hand limit. Okay, here's some notation. If we are approaching x equals a from the left, then we will use the following notation. So left-hand limit, we write LIM for limit, x with an arrow to a, and then a little negative sign here, f of x equals L. So what this is saying is that we are going to approach a. We're going to let our x values approach a. The negative sign means we're approaching from the left. And you can think about that like a number line. If you have a number line, all the values to the left are negative, all the values to the right are positive. So when we say the little negative, just imagine you're over here on the negative side, you're coming into the value from the left. So we're approaching a from the left, and we're saying that our function's value is getting close to something, L. Now, if we do it from the right, the only thing that changes is the notation. There's a little plus sign here, and that tells you you need to approach from the right. All right, when we want to evaluate a limit and we want to approach from both sides, okay, when I want to tell you, hey, look at it, inspect it, but go from both sides, what I do is I just write x approaches a without a little negative or positive up on the top right corner, and that means you've got to look at both. You've got to say, hey, what's happening from the left and what's happening from the right. And this is just a summary. In all of the notations above, L is the value that the function is approaching as x approaches a. X with the arrow going to a means x, let x approach a. L lim tells you that you're taking a limit, not just evaluating the function. And of course, f of x is the function that you're inspecting. All right, get this out of here. All right, here's the idea with pictures. Left-handed limit notation. What is the limit as x approaches 2 from the left of this function? Well, it should be equal to 8. Let's see. Again, we came in here, we're approaching the value x equals 2, but we're coming in from the left, so the function is approaching 8. We've seen that. right-hand limit notation. Now let's do the same function approaching 2 from the right, so that means that we are going to be coming in from this side. That limit is 4 because we're approaching a value of 4, a y value of 4. Now if I don't put left and right, a negative or a plus, and I just leave it like just 2, then that means you have to look from the left and the right, and you can see that from the left this one approaches 8, and from the right this one also approaches 8. So we had to inspect from both sides, and we got the same answer from the left and from the right of 8. Alright, moving right along here. The limit. So we call the left and right hand limits one-sided limits because they only look at the limit from one direction. The limit without putting the plus or minus means that you have to look from both directions, and for there to be an answer, okay, from both the left and right hand side. So for there to be an answer to this limit, the left and right hand limits must be the same. Alright, the function approaches the same value from both sides. In the event that the left and right hand limits do not equal the same thing, we will say that that limit does not exist, and we will just write DNE to represent does not exist. So when you're not coming from the left or right, you've got to look at, when you're not specifically from the left or from the right, like this is, you have to look at both, and if they're both the same, then that's your answer. If they're not, you say the limit doesn't exist. So here we go. This limit, as x approaches 2 of this function, does not exist. Why? Well, what's happening here is I approach from the left, I get 8. When I approach from the right, it's headed towards 4. So the limit from the left is 8, but that's not equal to the limit from the right, which is 4. Since these two limits are not the same from the left and right, this limit does not exist. Okay, a little bit more. How about this one? If I'm taking the limit as x approaches 2 of this function, I'm getting an answer of negative I think this should be 0.25. Yeah, I think that's a typo. As I approach from the left, remember what was happening is I was getting really close to negative 0.25. Yeah, that is a typo. And then as I approach from the right, I was also getting a limit approaching negative 2.5 also here. And since from the left and the right they're equal to the same thing, we have an answer. The most critical thing I want you to remember, though, is that the limit, there's an answer to the limit here, okay? It's negative 0.25. However, at 2, the function is undefined. That does not matter for us in terms of a limit. The limit can still have an answer even though the function doesn't even exist at 2. Very important concept there. All right, the definition of the limit. I'm just going to read over this. This is in the book. Let's not get too caught up in the language here. I'm hoping that with all the pictures and stuff I've shown you that you kind of understand. It says, suppose a function is defined near a, then we write limit x approaches a of f of x equals L, and we say the limit as x approaches a of f of x equals L. If we can make the values of f of x arbitrarily close to L by taking x to be sufficiently close to a on either side of a but not at a. Okay, this is all just confusing. Just go off of what I was saying from the pictures above. I just wanted to put this in here to be complete as far as notes are concerned. Alright, example, drawing a function with some given information about its behavior. So I'm going to do this in class. What we're going to do is we're going to take all these conditions and we're going to draw a function. And that's it for this section.